Okay, so today I'll be presenting on my project on an interactive reaction kinetics simulator, which is designed to model and analyze how chemical reactions behave under conditions. This project is based on fundamental principles on chemical kinetics, particularly the Arrhenius equation, which explains how the rate constant K depends on temperature. So the project is interactive. The user inputs four key parameters, which is what? The temperature, pressure, initial concentration, and simulation time. So you can input any temperature of your choice, which is like if you go by, let's say, 60 degrees Celsius, and what's temperature of 3 atm, initial concentration of 2 at 4 milliseconds. So when you run this, it gives you your values. So the rate constant calculation, it inputs how fast the reaction proceeds using the Arrhenius equation. Reaction rate determination, it calculates the reaction based on the concentration and pressure. The differential equation modeling, the change in concentration over the time is modeled using an ordinary differential equation. Okay, so the key outputs are the rate constant, the initial reaction rate, final concentration and concentration drop, and the half-life of the reaction. So in visualization, one can see the graphs at the top part of your screen. So the graph, this side is in correlation with concentration versus time. So here's the concentration against time. And this shows how the reactant decreases, indicating how fast the reaction occurs. The second one shows rate constant versus temperature, which is so the bottom part is the temperature and the y-axis is the y-axis is the rate constant. So this graph shows the increasing temperature significantly sped up in the reaction. The next graph shows reaction rate versus concentration, which demonstrates a direct relationship, meaning higher concentration increase. Finally, rate versus pressure shows that increasing pressure also increases the reaction. Okay, so now in conclusion, the project combines chemical theory with computational tools to create a powerful simulation. It helps students and engineers visualize reaction behaviors, predict outcomes, and better understand the effect of temperature, pressure, and concentration on the reaction. Thank you.